Welcome to All Techies. I'm Pankaj Rai, and in this video I'm going to talk about the Kotlin Flow. Well, you learn in this video about how you can get started with it, what is Flow, and also the operators that it is offering. But before I talk much about how we can get started with it, the first thing is what it is and why should we use it. So Kotlin Flow is one of the good way for having asynchronous flow of data, which means that if you need a reactive streaming in your application, then Flow is the best option for that. It's also treated as the alternative for RxJava. Well, now let's see how we can get started with this. Say if you already have a list of numbers, say 1, 2, and 3, and you want this to be a flow, not just the list, then what you can do is that you can do as flow, and the moment you call this function, it transforms this list to flow. Also, if you have arrange, say arrange from 0 to 10, and you want to transform this to flow again, then you could use as flow function. But this approach is for transforming to flow, not creating flow. So how you can create flow? So again, same like coroutines, as we have coroutine builders, here we have flow builders. And how to use flow builders, let's see that. Say I have a function, let me give this name as process number, and here I am using the flow builder. The flow builder name is flow itself. Inside flow I can emit any number, even string, number, double, whatever type which you want to emit here, you can do that. It could be your own model classes or just these numbers. So this is about the flow builder. We are building the flow and emitting the value. How we can collect it? Is it like I can call process number here and it's going to give me number 10? Then it's not going to work in that way. Flow by nature is cold, which means that until and unless someone is collecting the flow, emitter will not emit the result, which means that this block will not execute until and unless I call collect. So what I should do is that on this I should call collect. Now if I say log, it's going to give me the value 10. Rather than just emitting one value, let me emit series of values. So let me have for loop, and let me give this for num in 0 to 10, emit this number. Now if I run this, then you'll see the values getting printed between the 0 to 10. One thing is that I haven't added delay, so it will be like printed all at once. So here this all values got printed at once. Now let me do one thing, let me add a delay of 1 second, which means that after every 1 second print this value, because it will emit the number, and here we are printing it. So here you could see after every 1 second we are receiving the value. Main which you are seeing here is the main thread, because both collect and flow, they are running in the main thread. So one thing which you could notice here is that because both of them are running on the main thread, then how about if you want to do something which is like a process intensive, the CPU intensive task, which should not be done on the main thread? How you could do that? Like for example, flow is something where you emit the value. If this is a place where you're doing some intensive work, then you may not need this to run on the main thread. So for that, rather than switching the context like with context, dispatchers dot default, what you should do is that you should use one of the operator for that. So this is really not the recommended approach. You should not do that. It's all because context preservation. Flow does context preservation, which means that in whichever context this collect is called on, in the same context this flow builder will also run. The reason for this is because when you have a same context, then it need not have to create multiple coroutines. So it's not like one coroutine is for collect and another is for flow. When you do not have multiple coroutines, then there will not be need of any channel. But if you run flow in separate thread, collect in separate, then it requires two coroutines to act upon, and for their inter coroutine communication, it will need a channel for that. But because there are such scenarios where we'll need flow to run on the background thread and collect to run on foreground thread, then what we should do is that we should use an operator called as flow on. This is the place where you can define this flow builder should execute on which thread. Now let me do one thing. Let me also print log, and here let me give this as emit. So you'll see emit will run on some background thread, and this numbers will still be on the main thread. So here you could see that emit is in worker thread. These numbers are getting printed on the main thread. So this is really an easy way for context switch, where just by calling this flow on operator, you switch the context. Your collect remain as it is. How about if you want to put collect also to background thread? Then here it's very straightforward. You can certainly have dispatches.io here, or default whatever you want to have. There is no such issue here. Now let me run it once again. This time you'll not see main written for these numbers. Here you could see they both are running in the background thread. Okay, so this was all about how you can create flow, how even you can transform list or range to flow. Now let's talk about the intermediate operators. So here with this collect, I'm just getting the value from this, I'm printing it. How about if I want to do certain thing before I collect the value? For example, I just want to know about the numbers which are even. Then I could do a filter here, it mod 2 equals to 0. And now if I run this method, then I'll see only the even numbers. Not just this, how about if I want this number to be string, not the integer? Then I could call map and it dot to string. Now the value which I'll receive in collect, it will be of type string. So a straightforward way of using this intermediate flow, just like the way you use it with the list. We have one more operator which is quite widely used, and this is for emitting multiple values. That is nothing but transform. Say if I don't want this filter and map, I want transform where I want to emit multiple values. Then what I could do is that I could do emit it. Emit it is just going to emit the number, but before that I also want to emit some string. This is inside transform. So here we could see that the first emit is this, which is getting printed here. Then the second emit is just a number. So this sequence just follows on. First emit comes to collect, then second emit comes to this. So emit is already defined inside flow, but while collecting it, also if I want to emit certain things like transforming it to some other type or emitting new values to it, then we could use transform operator for that. Okay, so this was all about the intermediate flow, where you have seen about how we can use filter, map, and transform. Now let's see about the size limiting operator. Say I do not want this number to be printed 10 times. I just want it to be like 5 times. Then what I could do is that I could call something like take. And here I have to specify the number. So now it will just print values from 0 to 5 and then it will stop. And here you could see it's 0, 1, 2, 3, 4 and done. It's all because we have specified that we are just interested in the first 5 values, not beyond that. So by this way, it just understand that once you have received these 5 values, stop the flow. Now let's talk about the terminal operator. So terminal operator are nothing but the operator which are last in the sequence from where we receive the value. For example, you could see this collect. From this collect, we are receiving the value, whatever is being emitted from the flow. So here you could see, like, I'm just receiving the value and printing it on a log. But this is not the only terminal operator we have in Flow. We have more than this. So how about if I'm not interested in knowing the individual value, rather I'm interested in the summation of all these values, then what I could do is that I could call another terminal operator. Here is reduce, which takes two parameter, accumulator and values, and here we have to specify the operation that we are interested in. Here we could give like multiplication, division, anything, because we are doing it on number. So here let me do one thing, let me add both these numbers, accumulator and value. This is not going to return value to us, unlike collect, but what it's going to do is that we can collect this value, and here sum will have the value which has been reduced here. What is this accumulator and what is this value? So accumulator is nothing but the initial value, whatever you're specifying here. So it will be this default value. So 0 will be the accumulator and then 1 will be the value. Next time accumulator will be the summation of both of them. So let's do one thing. Instead of printing the sum, let me individually print the accumulator and the value. So let's have log accumulator and also log value. So my value start from 0 and go till 10. So for accumulator and for value, you could see here the initial value for this was 0 and then for this it was value 1. Now what it's going to do is that it's going to sum both of them. So 0 plus 1 is 1. Next time my accumulator value will be 1 and the value for this it will be the next value. So earlier we have received till 0, 1, now it will be 2. Again sum of both of them will be stored in the accumulator, so value remains 3 and we get the next series value. Earlier we received 2, now we'll receive 3. So by this way value receives the new value continuously and accumulator stores the operation value. Here for us it is the summation of both of them, and finally we get the value. But this may not be the ideal scenario in few of the situation where we may need some sort of default value. We do not want accumulator to take the default value from the sequence. Rather, we intentionally want to give some value from our side. Then during those scenarios, instead of reduce, we should use fold. Fold needs the default value. So here I could say like 50. So the accumulator value here will be 50. And again, the summation of both will be stored in accumulator. Let me run this once again. And here you could see the accumulator value here is 50 because I've provided 50 value first, and this 0 value is for value. Next time summation of both of them, 0 plus 50 is 50, so accumulator value again remains 50. Value the next sequence is 1, so 1. Again sum of both of them is 51, so accumulator value is 51. Now value is 2, summation of both of them. So that's the difference between reduce and flow. Reduce do not take any initial value, rather it get the value from the sequence. Fold takes the initial value for the accumulator. and from there on it just do your operation, either you specified addition, multiplications, or whatever operations you specified inside fold. Okay, so this was all about the terminal operator, where we have seen reduce, fold, and collect. If emitter is fast and collect is slow, what happens in those scenarios? So let me remove all these things. Let me write it once again, process number dot collect. And here let me do one thing. Instead of just emitting the value, let me also log it. So here it is emit, and let's see the number. Again here also, if we'll say collect and the number. Here the delay is 1 second, so let me add a delay of 2 seconds here. So here, as I've talked about, collect and emit, they follow the sequence. First emit the result, collect has to receive it. Until and unless collect do not receive the value, emit will not emit it. And here you could see it's getting delayed by 2 seconds. That's all because here in collect we have intentionally added a delay of 2 seconds. But as I talked about, this may not be the ideal scenario in few other cases. In few other cases we need this emitter to just emit the value, and whenever collect is free it could take those values. Then for that, what we need to do is that we need to have a buffer here. So the moment we add buffer, what it's going to do is that it's not going to wait for collect to receive the value. Rather, what it's going to do is, like, emitter will emit the value continuously, store it in buffer, and whenever collect is free to get more values, it will just get from the buffer. But before that, let's also see about the time difference. So let me do one thing. Let me put it inside the measure in time. Measure time in millis. And let me put all these things inside that so that we'll know about the time difference. And eventually, let me print time. After this, we'll see what happens when we call buffer there. So here you could see the time in millis is 33,262, which is nothing but roughly 33 seconds, because it was following the sequence, the emit and collect sequence. Now what I need is a buffer, so that emit will continuously emit the value and collect whenever it is free, it will get the value. Now let's see the time difference. Here it is. Earlier it was 33,000, now it's 22,238. That's all because now collect and emit, they are following the sequence, but emit is not getting suspended because of collect, as collect is busy in doing its operation. Okay, so this is about the buffer. And the final thing which I'm going to talk about is how you can skip certain values. Think of the case where you are just interested in knowing about the recent value, not the intermediate values. What are those intermediate values? Like, say here in our case, collect is having a delay of 2 seconds and emit is having a delay of 1 second, which means that for every 2 emit values, collect will suspend itself. But how about if I'm not interested in knowing the previous value, I just want to know about the new value? Then during those cases I could call conflate. And let me run this once again. So here, by using conflate, what you'll see is that you'll not see always 0 and 1 getting printed. Rather, you'll see different values for collect. So here you could see earlier the collect value was 0, then 1, 2 got emitted, we got 3, then we got 5, then 7, 9, and then finally 10. the overall time reduced to 14,216. It's all because it dropped the intermediate result and give the latest value for processing inside this collect. So by this way, if you are just interested about how you can know about the latest value but not the previous one, then you could use conflate. We also have collect latest, which can do the same work where it will give you the latest value. So before I conclude this, let me also talk about zip and combine. Let's have one more flow, process num over 100. Let me create flow once again here using the flow builder. Again, a for loop ranging from 100 till 110. And here it's just going to emit this number. So exactly same thing what we are doing here. We are doing same thing in this function also. But one thing that we are doing here is like instead of running between 0 to 10, now we are doing it 100 to 110. So with zip, what we can do is that we could take the value from this flow, also value from this flow, and eventually we could combine both of them. So let's see what I mean by this is instead of conflate, now I'm going to call zip. So it's taking the first flow, and inside zip I have to provide second flow. Eventually I also need to provide this inside lambda that what I'm going to do with these numbers. So let me do one thing, let me add both of them. So what it's going to do now is it's going to get the value from this flow is individual, like 0 will be the first one, 100 will be the second one. So num1 will be 0, this will be 100, 0 plus 100, and I'll get here 100 as a result. Next will be the 1 and 101. So the value which I'll receive here is 102. Let me remove the delay of 2 seconds here and let's run this. So here you could see, as I have given this information that I want summation of the individual numbers, so it is doing that. But here so far so good because I have same number of iteration. Here also it's iterating for say 11 number of times, here also it's 11 number of times. But how if I just have 5 iteration here, run from 0 to 4 and here 0 to 10. Now what happens in this scenario is that it takes a precedence over the smallest number which both of the same is having. So here you could see it's just doing for 5 times. So it's not like the buffer overflow exception. It's all about whichever is having the smallest number, the size of flow, it takes the precedence of that and it runs another flow based on that size only. By this way you do not need to bother about the flows have to be of the same size. It's not like that. And this is okay, all good. Now we have a flow with different sizes. Here it's 11, here it's 5, but the delay is again same. How about if I have more delay in this flow? So this flow is emitting result quite fast. This flow is taking twice that time as the previous one. Now what happens in this scenario? Well, in this scenario also it takes the precedence, and the precedence will be the highest delay by any one of this flow. The highest delay here is 2 seconds. So what it's going to do is that on every 1 second it's going to get this value, but it will not process it. Once it get the value from this flow, then only it will process this lambda part and eventually will come to collect. So by this way, using zip you can combine two different flow and get the result as one. We have another operator here called as combine. How it is different from zip? So the difference between combine and zip is that for every value change in the flow, it executes this lambda, eventually it comes to collect. Unlike zip, where zip wait for both of them to complete first for the initial value and then executes lambda come to collect. Combine is not like that. Combine gives the value for every value change. So if you have a same delays, well and good, you'll see individual values. But if you have delay of different variations like 1 second here or 2.5 seconds here, 1 second here again, then you'll see value more than 10 times. It's all because based on the value emitted from the flow, this part gets executed, so you'll see the value on the screen. So this was all about the Kotlin flow in a single video. If you have liked this video, then do not forget to hit the like button and do subscribe this channel so as to get the videos on the latest topics of Android, Kotlin and Firebase. Thank you and stay tuned.